Alright, section 9.2 is graphing and writing equations of parabolas. And now that you watched the introduction video, hopefully you jotted down all the formulas. And if not, remind yourself that if you have a vertical parabola, and that's one that you're probably familiar with, you know, opening up or down. If it's opening up or down, your vertical parabola equation is x squared equals 4py. If it's a horizontal parabola, you know, like opening to the right or to the left, then you're going to have y squared equals 4px, so just reverse of the vertical. Also remind yourself p is the distance between your vertex and focus point. And if you go in the opposite direction, you get your directrix line. So the two important characteristics that you're going to want to find, other than your vertex, of course, is the focus point and the directrix line. So important characteristics that you're going to want to have to list out. Alright, this first example says graph x equals 1/2 y squared, and then it says identify the focus, directrix, and axis of symmetry. Note that these are called important characteristics, and on the test it will just say identify important characteristics and not remind you of what those are. So first I noticed that the y is squared. X equals 1/2 y squared. I also note that to be in standard form, it should be y squared equals 4p times x. So I should probably solve for y squared, which is very easy. I'm just going to multiply by 2, right? So then I'm going to have y squared equals 2x. And I note, because the y is squared, that I'm actually going to have a horizontal parabola. And I also note that it's going to open to the right because my 2 is positive by my x. If it were negative, it would open to the left. I can also easily solve for p, so I know that 4p and 2, since everything else matches up, right? So 4p has to equal or be equivalent to 2. Not that you have to probably write this out, but divide by 4, and 2/4, of course, is a half. So I know p is the distance from my vertex, which, by the way, I'm going to fill all of this in, my vertex, because there's no shifting, which I haven't talked about, but there's no h or k shifting, horizontal, vertical shifting. My vertex is going to be at the origin. My focus point is p units from my vertex. So in this case, since it's horizontal, I'm going to go to the right 1/2 units, because that's what p is, to the right, so it's going to be at 1/2, 0. And my directrix line is always the opposite direction of my focus point, so I'm going to go to the left 1/2 units, and that's going to be a vertical line since my parabola is horizontal, so that's going to be x equals -1/2. Now I'm going to go to the graph and I'm going to blow this up, so maybe pause the video and jot down this stuff before I go on to that. Okay, and I'm just going to jot down the equation again. I had y squared equals, what was it, 2x. All right, so y squared equals 2x. And I know that my focus point is at 1/2 and my directrix line is at -1/2. Okay, so my focus point, I'm going to actually scale by 1/2 here, just so that you know. So my focus point is at 1/2, so we'll say that's there, and my directrix line is x equals -1/2, so that would be there. And then my parabola is going to be centered at the origin, and then I have to know how wide or narrow this is, so I would just test a few points. You really don't need to test that many. And I would probably put some values in for, actually, you know what, I'm going to solve this equation back. I'm just going to divide that 2 over here. Not that it really matters. But I'm going to put in some y values now because I think it'd be easier to square some things, multiply by half, and just get x. You can use any equation, obviously, any form, so you do whatever you feel like works best for you. So I'm just going to, since I already know the origin, I'm going to maybe do y equals 1 and 2, and I'm going to see if that's possibly enough. So if I put 1 in for y, 1 squared is 1, half of 1 is 1/2. If I put 2 in for y, 2 squared is 4, half of 4 is 2. So, excuse me, I'm going to plot this point first and remind myself that I scaled by halves. So x is 1/2 and y is 1. And I know that parabolas are symmetric, so I'm going to graph 1/2 and -1 also. And then my other point is 2, 2, so that's actually 4, 4 if I scale by halves, right? So 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4 in the opposite direction, and that to me is enough. I can see how wide this horizontal parabola is. I can see my axis of symmetry is y equals 0, and there's your graph. And I will bring this down again so you can kind of take a peek at it if you want to jot more things down. All right, I'll go through this one a little bit quicker. It's very similar to the last one, except note that x is being squared instead of y. So I'm going to first note that it should be, let me erase this. If my x is squared, standard form is x squared equals 4py. So I'm going to solve this equation for x squared. So it's going to be, I'm going to multiply by -4 on both sides to get rid of the -1/4. So it's going to be -4y. And now my x squares match up, my y's match up. So I know 4p has to equal -4. And it's pretty easy to see, if I solve for p, that p is going to equal -1. So because x is squared now, I know this is going to be a vertical parabola. And I know because the -1/4 is obviously negative, it's going to open down. And I know that my vertex, because there's no shifting, will be at the origin. And from my vertex, I'm going to go -1 units to find my focus point. Because it's vertical, I'm going to go down 1 unit. So it's going to be at 0, -1. And my directrix line is always opposite p units, so since I went down 1 to get to my focus point, I'm going to go up 1 to get my directrix line, and that's going to be a y equals +1 since I have a vertical parabola. Now again, I'm going to blow up my graph, so if you want to pause and jot this stuff down, you certainly should do that. Okay, so I know that my vertex is at the origin. I know my focus point is at 0, -1. I think I can scale by 1s, so I'll just scale by 1s. So my focus point is at 0, -1. My directrix line is at y equals 1. And I'll use a different color here. So my vertex is at the origin. And again, my equation is x squared equals -4y, or maybe still easier to do -1/4 x squared equals y. It really doesn't matter. I'm going to plot just test just a few points. Again, probably easier to test x values and square them and da-da-da to get y. So I'm just going to maybe do 1 and 2 and see if that's enough. So 1 in for x, 1 squared is 1, -1/4 of that is -1/4. 2, put it in for x squared is 4, and -1/4 of 4 is -1. So maybe I'll do one more. Maybe I'll do 4. So 4 squared is 16, -1/4 of 16 is -4. I'm not going to plot the 1 just because -1/4 is going to be tiny, tiny on there, but I can certainly plot 2, -1. So I'm going to go over 2 and down 1. And I also know that I can go -2 and down 1 since, again, parabolas are always symmetric. And I can go over 4 and down 4. And that's a point. And then I know, again, it's symmetric, so -4 and -4 will be a point. And that is definitely enough. I can see how wide this parabola is. Also note you can certainly use pattern of change if you recall that, but really the requirement for conics is just test enough, 2 points is really enough. And then of course you know the reflection. I think you know enough about the reflective nature of parabolas that you can easily, get a feel for the graphs. So I'll kind of make this smaller and you can jot down whatever you need to jot down. Okay, last problem, I'm going to kind of switch up the scenario here. It says write an equation of the parabola shown. So notice you have, you'll either be given information about it or an actual picture. So first and foremost, things I might pick out. Well, it's obviously a vertical parabola, and it's opening down. So I know that it's going to be a negative something. And because it's vertical, I know that the x is squared and not the y. So I'm going to go this route. And it's centered at the origin, right? I know the vertex is 0, 0. I can see that, so there's no shifting. And I can count here that the directrix line is 1, 2, 3 units, so that equation would be y equals 3. So it's 3 units from my vertex, which means my focus point, although you don't see it here, would be 1, 2, 3 units below, so that point is 0, negative 3. So P is the distance from my vertex to my focus point, so P is going to be negative 3. You could say 3 since you're thinking distance, but it's also directional, so always go to your focus point. So if it's below and it's negative 3, then P should be negative. Otherwise, you're not going to get the right sign on your equation. And I know now really everything I need to know, so it's quite simple. I know x squared is going to equal 4py, but I just figured out that p is negative 3, so x squared is going to equal negative 12y. And that is my equation in standard form.